Okay, so welcome to day 5 of your challenge. I've given you something that looks like a bingo board, but this is something that'll help you organize what can happen depending on the strength of your nucleophile or base. So at the left we have substrate, and at the top we have our strength of our nucleophile or base. So here if we have a methyl with a leaving group as a substrate, and we have a very weak or non-basic thing, think about water or alcohols, really there's not going to be a reaction. These are super slow to react. If you want to do something with a methyl with a leaving group, you can't form a carbocation, so there's not going to be any SN1. E1, we don't have a beta carbon. SN2 and E2, well, E2 can't work. We only have one carbon there. And SN2, you need a better nucleophile here. And water or ethanol is not really going to work. Okay. With the primary carbon with a leaving group, the same thing is going to happen because we don't have a good enough nucleophile to really do a proper SN2 reaction. It's going to be extremely slow, extremely slow. So no reaction here. For the secondary carbon with the leaving group, we can form a carbocation. So you might want to write a little note here. Okay, now we're getting in carbocation land, and if we have weak base or non-basic things, that carbocation can form. This is where we can get a mixture of SN1 and E1. So SN1 and E1 can happen here. Okay. If we have a tertiary carbon with the leaving group, you betcha we can do SN1 and E1. We always get a mixture. So SN1 and E1 can happen for both of these bottom two reactions. We really talked about how E1 is really best to use with an alcohol, and then you add some kind of a strong acid like H2SO4. So you might want to write something like that down. And you also might want to write here that if you start with one chiral center, okay, this is going to racemize. You're going to then get both R and S for both of these, okay? Just something to note here for both of these two down here. When you have chiral centers, you will racemize. So this is another way to write it. You could just write racemizes the carbon, the alpha carbon, whatever works for your brain. Okay, let's go now to something that is a little more basic, okay? And so here we're thinking about things that are a little better nucleophiles, and you might think of some kind of a thiolate, okay? You can also think of like cyanide, okay? Actually, halides are good leaving or good nucleophiles as well. You could also think of amines. Okay, so these are good, pretty good nucleophiles. And so for a methyl here, you will get SN2. So the SN2 will occur. For the primary, SN2 will also occur, okay? And for our secondary carbon with the leaving group, we have a good nucleophile, but not a super strong base. So SN2 will be favored, okay? And here is where we have to start worrying about this inversion. So you could get an inversion of this stereocenter if it's chiral. So you might want to write that note down. And what happens here for our tertiary carbon with the leaving group? Well, some of our bases and great nucleophiles are really good for SN2, but not so much for SN1 and E1. This substrate can only do an SN1 an E1 or an E2. But when we look at our base and great nucleophile, we can't do an E2. We don't have anything strong enough for that. You might get some SN1 and E1 depending on what you're starting with. Okay, depending on what you're starting with. So we're going to write SN1 and E1 down as options for this. Okay, and so now let's go over to strong bases. These are things like ethoxide, methoxide. These are two of the most common ones that we've used. And actually, if you take an alkyne, this can also give you similar reactivity. So I'm going to write a negative charge here. Okay. For the methyl group here with a leaving group, we're going to be doing SN2 again. Can't form a carbocation, and it cannot do any E2. All right, what about for our primary carbon here with a leaving group? Well, we can definitely do SN2. And this is going to be favored over any E2. Remember, we have a really strong base, but this is going to react SN2 first because that primary carbocation is easy to attack. All right, this is where it starts to flip. This secondary carbon with a leaving group with a strong base, it's actually going to be favoring E2. Now you will always get some SN2, but we're going to say it's favored in E2, and that's typically the, when you look at literature, it's typically the percentages is favored in the E2 sense. And since you don't have an organic chemistry lab at hand, I'm not going to ask you the percentages, but just remember that E2 is typically favored. And then for the tertiary with a really strong base, we know we can't do SN2, it's too hindered, so E2 will be favored, okay? All right, now let's look at a strong bulky base. This has a little bit different rules here. So this strong bulky base for a methyl with a leaving group, it can do an SN2. Now for a primary though, it's too bulky, and then now this group has this extra carbon on it. And this is not going to do an SN2, and instead, because it's so bulky, it's just going to try to pick up a proton. It's going to do an E2 reaction. This is really the one that I think is easiest to kind of flip up. So it's these two that are a little different here. Although it can do SN2 for the primary, its E2 is favored. The same is true for the secondary carbon with the leaving group, E2. And then, of course, we also do E2 here for our tertiary. Now, one of the things that we also want to write down in here is like preference of alkene. For the bulky base, remember that we're going to be following the most easily accessible proton. This is a really bulky base. So you're going to get typically you're going to get the least substituted alkene. So you might want to write that down. Typically it's least substituted. This is going to be the fastest to form. And then if you have a small base, so these are small, you're going to follow Zaitsev's rule. And you're going to get the most substituted. Let me know. Oh, Rhodey just ran inside. So that's it for day 5. I would highly suggest writing more notes than I have on here. You might find yourself writing even specific examples, but this is a good way to kind of get an idea about where to go. When you have a reaction, I like to look at these two main things, substrate or the nucleophile and base. Now we can go ahead and write in our desired solvents that typically work well, like which solvents work best, right? So on this top left, this weak or non-basic, we're looking at polar protic. We typically use polar aprotic here. And you can kind of decide what's going on also with the solvents in mind. But remember that the nucleophile and base in conjugation with the substrate, those are our two main things that are dictating what's going on with the reaction. Solvent tends to just affect the rate. That's it for this video. Hopefully this helps you with organizing. And again, make sure that you're writing down things that work for you. Everyone's brain works differently. So here is just a nice starting point for you to work from. All right, I will see you all in the next video.